Hello and welcome to hour 5 of refactoring practice. Today we're going to be doing similar similar practice to what we've been doing so far. It's going to be the Gilded Rose kata. The goal today, I think, is going to be to try to get far enough along that we far enough along that we can get the new functionality added, which is the point of the Gilded Rose kata in the first place. Just a brief kind of review here. In the Gilded Rose kata, you're given this inventory system, and you're tasked with adding a new kind of item. You can see that there are different kinds of items by name. Here we got HPRE, backstage passes, sulfurous. And you have to add a new type of item, a conjured item, and that item degrades in quality twice as fast, I believe. But the problem kind of begs you to refactor the existing code so that you can make it easy to add the new type of item. All right, so let's get into it. The first thing that we're going to want to do is watch these tests run here. And actually, let's get the production code in a split here. All right. So we can see we get a test failure, expected fix me, got foo. Let's change that right away and get these tests passing. And actually, let's just do that there. Okay. So we're going to get our fast feedback loop going. All right. And I just want to turn off that code analysis check because we're going to need it. Okay, so now that we have our test passing, let's do a little bit of cleanup here. We're going to turn this into a require relative. We're going to clean up some of the white space. And like a 4-phase test to be clearly delineated. So we go with that. We'll remove the extraneous parentheses there. Watch our test pass and call it style fixes. Okay, so that's the boring stuff. Actually, there's one more thing we can probably do, and that is get a more conventional Ruby project structure with lib and spec folders or directories. So if we move this Gilded Rose spec into spec, you can see IntelliJ takes care of that. And then if we move this into lib, we can you can see IntelliJ took care of that. So that's pretty good. I don't mind that. All right. So one of the things that we're going to want to do before we start refactoring kind of in anger is ensuring that we have tests that can cover all of the existing behavior. I've got code coverage on right now, and so we can see in the gutter any lines that are green are covered by the existing tests. Any lines that are red are not. We can see there's tons that aren't covered, that isn't covered here, and we want to make sure that our refactoring doesn't change any existing behavior. So what we're going to do is add something called characterization tests, and the best way that I know to do that is with a tool called approvals. So if we go to our gem file here and add approvals and run our bundle install. We should end up in a place that we can use this tool. It takes a while to install, so maybe I will. Oh, actually, we're good to go. So let's go back to Gilded Rose here. The way we can use this is with this approvals RSpec, and approvals gives us a block called verify, or a method called verify, and maybe I can see the documentation on this. Okay, so we can't. But anyway, it gives us a this verify block. Actually, let's take a look at the API. I think we've got a little bit of time that we can spend better acquainting ourselves here. And so what approvals does is it creates these output files, and the output files contain serialization of the subject under test. And so what it allows you to do is you can generate all of the interesting outputs in a test for the thing you're testing, and have those outputs saved to a file. And then every single time you run the test, approvals will verify that the outputs that are in that file match the outputs in the current run of that test. And this, if they do differ, then approvals gives you tools for approving any changes that you might discover, but otherwise it'll fail the test. And so it's a really excellent way of building up these characterization tests without having to get into the nitty-gritty of asserting that each input associated with each output. And so the thing that we want to, if we look at what update quality does, it appears that you pass in an array of item objects to Gilded Rose's constructor. You call update quality, and it looks like what it does is it actually mutates each of these item objects. And so what we want approval to check is, in its output file, is some serialization of the items. And so what are the items going to be? Well, the items are going to be, it's going to be very similar to this existing test. And actually we can just sort of watch what this looks. We can take a look at what this looks like right now. So we can see approval error, that the approval file isn't found yet for that test. If we bump back into terminal here, we can do approvals verify, and we can see that the approvals tool runs a diff on an existing approval file against the received file, which is the one for the current test. And right now, approvals looks like it's just doing a .inspect or like a 2s maybe on the item class. And that means that this object ID is in there. And so this is going to be roughly unique every time we run a test. And we don't want that, because we want stability between test runs. So we want just the things that are important to us, the name, the cell, and quality. So right now we're not going to approve that. And instead we're going to map it. I happen to know from other practices that there's a 2s method that has all of those bits in there already. And so we can run this again, and we'll bump back over to terminal, do another verify, and we can see that we have something that's stable. So let's approve that. And let's commit that change. Now, it's all well and good that we have this items array, but we still want to hit every interesting case here. And so what we're going to do is like a very cursory read through of this code to find what might be interesting test cases. I mean, those are usually based around conditionals. So it looks like the things that are important here are name, quality, and selling. So let's try to generate all the interesting names, all the interesting qualities, and all the interesting sell-ins. So for our names, it looks like the very first one that's interesting is this aged brie. And we also have this backstage passes. Oh, fat fingered that a little bit. And we have this sulfurous name. And that looks like the only useful name. So but we do have this foo down here too. So let's stick that in there. All right. So we have all the interesting names. Let's look at the qualities. So we have 0. And what you should do when you're trying to cover these is hit every side of the interesting kind of comparison. So -1, 0, and 1 is what I put in there for 0. We can see that there is, like here, we can see there's a 50. So let's do 49, 50, and 51. On the quality, there's another 50, there's another 50, and yeah, that looks like all the interesting qualities. For sell-ins, we can see that there's this 11, so let's do 10, 11, 12. There's a 6, so let's do 5, 6, 7. And there's a 0. So let's do -1, 0, and 1. All right. So that does it for sell-ins. Now what we need to do is take these like interesting I guess, attributes and turn them into inputs for the function. The best way to do that is to try to have every combination of name, quality, and sell-in could be a potentially interesting test case. And the way we can do that is take the cross product of names with qualities and sell-ins, map, we get a name, we get a quality, we get a sell-in, and we're going to map this to a new item. All right. And now when we run this, we should get a failure. And we can see that the failure is that the file doesn't match. So it's a little bit different than when when we originally ran the test. And we can see now that what we have is 200 some odd interesting test cases that we've generated. And the other thing that we can see in the green here is that we fully covered the existing, we fully line covered the existing code. So this is going to put us into a good place where we can be confident that we have full characterization of the existing behavior, and we can now feel free to start kind of refactoring. I do want to get this running. Okay, so that actually should. Sorry, we forgot to verify. I'm just going to amend my existing commit. Okay. So when we run, should be good. All right. And that should do it for the testing portion of this. We can now focus on just refactoring the existing code. So to get off to a bit of a start here, let's clean up the style on this a bit. That's probably enough. Style fixes, or fix style. And I'm not quite sure why this isn't automatically running. Let's try to get that automatically running so that so we end up in fast feedback mode. Let's see if we can get it here. Right. Okay. So it looks like we're good. First thing we probably want to do is I like to use adder readers internally for any instance variables. This is called the principle of uniform access or something like that. But I just find that it's just easier to refactor if we use the same way to refer to instance variables as we do to methods. Yeah, we can add those. Okay. So let's add reader for items. Actually, I forgot to set a timer here. So let's say we're about 10 minutes in. All right. So it looks like update quality iterates through each of the items and then updates those items. It might be useful just right off the bat if we could extract this method into or extract the contents of the each block into its own method, and we'll just call it update. And now this reads a lot easier. So we can see update quality iterates through each of the items and updates them. We're still passing, so we'll just call this extract method. And now we can see that we've kind of isolated the gnarly code. And when we have like big, deeply, or large, deeply nested conditionals like this, it's helpful to start peeling out each of the conditions one by one. Since we are updating each item and it looks like the switch is based on the item's name, it might be helpful to pull, or it looks like what'll be helpful is if we pull out each name condition one by one, starting with h-free. And the way we do this is first by kind of adding an empty conditional with the condition we'd like to lift out first. And then what we do is, well, actually, let's commit that. We want to commit frequently here. So that's a safe change. That doesn't change the behavior of the code in any way. But if we can then, let me just get the keyboard working here. Okay, if we can extract this logic into its own method. It's very interesting. Let's just do this the old-fashioned way. I usually like to, no, let's not do this the old-fashioned way. Let's use the tools that IntelliJ gives us here. Call this applesauce. So we get this. We get this method of extraction is going to let us duplicate into either side of this if. And then we can use the code coverage indicators to tell us which code is dead in each condition. And that's how we can lift out these conditions one by one. So let's commit this. And then we can, after we watch the test pass, we can commit this. So duplicate condition. And then what we want to do is we want to inline this method. We do not want to keep it. Okay. Inline method refactoring is not supported when return statement interrupts the execution flow. That error message means that there are multiple ways or multiple values that can be returned from this. It just so happens that we know that the only thing this method is doing that's useful is mutating the item object. And so we don't actually care about the return value here. And so we can always make this method return nil, and then the inline method refactoring should succeed because the editor can verify that the return value is going to be the same on either side of this condition. So now when we run inline, we don't want to keep the method, but that succeeds now. All right, and now we're in a place where we can start removing the logic that doesn't apply on this side of the condition. So anything that's, remember we have full test coverage, and so anything that's red here actually doesn't matter when this condition is true. And we can kind of see, we can work through this logically by replacing things that are always true with the constant value. So we can see if item name equals age brie, then we know item name does not equal age brie is false. And false and anything is false. And so we can see now why this here doesn't ever execute. So let's get our getter working again. And we can say that is not valuable. And we can say that this is not valuable, and that this is not valuable. And then we have this here, this whole if statement doesn't run. And what else? This never runs. And that's actually on the other side of the if. So we're simplifying both sides of the conditional, which is useful. Now that we've removed the dead code, though, we can start to simplify the remaining code that's there. We can see that this is just an empty if, so it's a no op. So we can remove dead code might have been a valid name there. We can also see that this is empty on this side, so we're always running the else condition. And our test should pass. We should get I've actually made a mistake there. Oh, cancel. Okay, sometimes I don't know how to use my editor. Okay. Looks like I've already committed that. So, okay, we lift this. Watch the test pass. We can see that this is another empty case, so we can lift that. Simplify if, and then if item name doesn't equal solve for it first, we know this is always true because item name equals age brie, and so we can simplify that too. Now, let's see if there's anything on the other side here. Looks like there's this empty else side. So we can actually lift this up. All right, so now we can do that same kind of larger refactoring there for the next item name. And the way we're going to do that is by extracting the else branch again into its own method. We then, oh, actually, let's commit that. Oh, we are going to do the backstage pass case now. And we should get test our passing tests here. And then once we inline, we don't want to keep the method. We can see, again, we're in the same place, only this time we're doing backstage passes. So this code is dead. And looks like this code is dead. Let's watch the test pass. And looks like all of this is dead. Right? Looks like this is dead. Okay, so we've now got backstage passes, all the dead code removed. We just have to simplify those if conditions again. First thing we can do here is we can see that this is an empty consequent, is what that's called. And so we can simply replace that if statement with the nested one. And then item name is equal to backstage pass, so we know this is true. And so we know everything inside of it is always going to run. And we can just pop that up there. We also know that if item name is backstage passes, that it doesn't equal sulfurous, so we can replace that with that. And this only has an else condition, so we can replace that there safely. And then on this other side, it looks like we have an empty else here, so we can replace that. And it looks like we have an empty else here. Oh, where did we have that empty else? Yeah, we have an empty else here, and so we can replace that. All right, and so we have backstage passes and HBRE done. And one of the nice things that that's happening here is we can see that only the sulfurous item name is referenced in this else branch, and that HBRE and backstage passes, those references don't exist in any of the code. So we know that when we lift the conditionals, we're actually simplifying the code by quite a bit. And so we only have one more of these to go. Let's do that. I think this. Okay, I'm gonna get the keyboard shortcuts here. I'm using applesauce because it's a ridiculous name that would never get past code review, which is kind of the point. It's supposed to be a temporary name. Okay. duplicate. Let's just get our test passing here. Duplicate condition. And then we want to remove the method when we inline it. Watch the test pass. Right. All right, and so we can delete that code. I'm gonna delete all of the dead code here. And actually you can see that like all of these ifs don't actually do anything, so all of them are dead. And we've now shown what sulfurous does, which is nothing, it says, seemingly. So it looks like if the item's name is sulfurous, the quality and the selling don't change at all. So even just by refactoring, we're starting to gain an understanding of the business logic underlying the code. We can also simplify these conditions. Item name doesn't equal sulfurous is going to be true in the else case because we've already covered it up here, and in the other ones. And so we can replace these with if trues. And if they're true, then that can go in there, that can go in there, and that can go in there. And so we simplify ifs. And remove extra white space. Okay. So now we have each of the items update logic pulled into each of these conditionals, and we can start to kind of pull away at the code here. Ultimately, like Ruby's an OO programming language, and what we'd like to see is maybe some objects representing each of the items. And one of the most simple ways of doing that is extracting method objects, or extracting commands, I think is what Martin Fowler's calling it in the new edition of the refactoring book. And we can do that just by introducing, I thought that would have been the class. Anyway, by introducing, basically extracting large chunks of logic into their own method on their own object. And it's kind of the simplest OO-ish refactoring that you can do. It's a little bit more than extract method, but it can help you move towards an object design. So it looks like each of these bits is an updater. So I'm going to call my object updater, and we're going to have it wrap the item. And we're going to do an add a reader. I should probably have a snippet that does this for me. And we're going to do, say, introduce class. And actually, having this add a reader is going to pay off big time here. So, because it means we can just, or we're going to essentially introduce an update method here. And we can see that item is the only kind of bit colored in orange, which I think means that it's a reference or something, maybe. I'm not sure. But we can extract this logic into here. Actually, let's copy paste it rather than cutting and pasting it right now. We can see that that's like syntactically valid right now. It's not being run, but it means that we can replace all of this with age-free updater new item dot update, and we are going to want to do that. Let's watch our test pass here. Yeah. We're going to want to do that with each of these cases. And, so we've got age-free updater. We're going to want a backstage passes updater. Let's copy first. New item. Cool. And let's try a different. Well, actually, let's do the sulfurous updater. This is going to be the simplest one, obviously. Item equals item. Sorry for the typing. And the sulfurous updater doesn't do anything. So what we're doing here is intentionally making it look the same as these other cases, because I think what we can, or by doing that, we're going to end up in a spot where we could start to think about removing the conditional altogether, and just have a mapping of names to updaters, and use that mapping to call the update method. Finally, we have this last bit. Let's use it. Yeah, we can call that extract method object. Let's see what we can do about, or if we can do this method object extraction in a different way. So let's call this update base item. And we're just going to create a base item updater. Base item maybe isn't the right word. Basic item. We'll do that. And what I want to do, I want to move this method. Okay. What if I extend gilded rows and I use push members down? So we want to push update based item down. What if instead I make this extend the basic item updater, and then I refactor this by pushing this member up, or pulling this member up. So we're going to move that into update base item. And then, actually, I don't think this is going to work. We've got to do this just in with our fingers rather than the automated refactorings, unfortunately, it looks like. So we're going to create an update method again. Copy this, paste it here. And we will create a basic item updater, the item, call update. And we can inline this. All right. So now we have what it's starting to look a lot more uniform here. Let's remove the no because we actually don't care about that. I don't think that has a material effect on. Right. Move unneeded. How do you spell unneeded? Return value. And at this point, we could add the conjured item, but I think we can go a little bit further with the refactoring here. So anytime you see a switch, like anytime we see duplication like this, we can start to think about these rules called the flocking rules. And the flocking rules are: you spot some code that looks similar, you then find the smallest difference between those two blocks of code, and you get rid of that difference by making a simple change. And so what we can see is like the bodies of this code look awfully similar. And the only thing that's different is that class name in the front. And so the thing that we can do is extract this class name into a variable, and with with that variable being, and then just switch the contents of that variable. And then that should make this line the same in every single condition here. So let me show you what I mean. Let's see. Introduce variable. We're going to call this update. Oh. Okay. Let me try this again. So the shortcut was V. Data. All right. So we can see that works. We're going to call this updater. That works. That works. That works. Right. And so now we've got this introduce variable. Refactoring, and we can see now that this line is identical in each of these, and so we can push that down a level. We can basically slide that out of the conditions. And there's another thing we can do because Ruby is expression based. We can actually just return the updater class from this conditional. So we can do that, and this is the same behavior. And actually, now we're getting to a point where it's starting to look a little, or not a little bit, it's starting to look exactly like we're doing a lookup in a hash table. And when we can make a simpler refactoring that changes this, like, essentially case statement into a lookup in a hash map fairly easily. So let's say names to updaters equals, and we are going to do let's say aged brie. Sorry, this is a bit clunky. Ooh. And these are gonna map to their updaters. So aged brie updater, backstage passes updater, and self-viewers is updater. For whatever reason, all of our examples are getting, oh, okay. It's just mad because it's it's a constant, it's always a good idea to freeze a mutable object. Okay, so for whatever reason, an error occurred there. Using hash rocket syntax, it's possible that this can't be under the private. Oh, uninitialized constant gilded rows HB updater. Okay, so I think what is happening here is constant lookup shenanigans. So basic item updater, aged pre-updater. I jumped. These have all been declared globally. This doesn't need to be a constant right now. So let's do that. Let's just say so that passed. And what we're going to do is just look up in names updaters, we're going to fetch the item's name, and we're going to fall back to basic item updater. And now we're starting to see, like, this looks suspiciously like a factory constructor. And usually what I do in that case is actually move the factory constructor out. And so we can see that the only thing that the updater is constructed, the updater is constructed based on only the item. And so what we would like probably is updater, something that looks like this, updater from item dot update. We'd like to replace that whole thing like that. And so let's try to do that now. And what we can do that in Ruby is we can move all these updaters into as nested classes in an updater class, and then create a factory method. In this case, we're going to construct an updater from an item, and this is a very violent refactoring. Like, there's lots that can go wrong here. But now we've got this updater kind of updater from factory constructor, factory constructor like method thing, and we're just calling update on whatever that returns. And so now gilded rows is very simple. Actually, let's extract factory bucket. We can inline this even. And I don't know what the hell is going on here, but the refactoring tool didn't quite work. And somehow along the line, we managed to break something. Actually, let's just roll back. Okay, so we're good. Okay, so we're good, but what we'd like to do is just inline this method because now it's not doing anything. And since the automated refactoring didn't work so well, we're just going to inline it ourselves. All right. And now I think we're in a spot where it makes a lot of sense to add that conjured item updater. And we can do that. Well, first we should probably extract this to a constant. So we'll do names to updaters. It's interesting that this is uninitialized constant updater aged Brie updater. So I wonder if it's just that it can't find it because it's not introduced. So maybe these all have to be at the top of this. Oh. First of all, sulfurous that updater isn't actually in the class yet, which is a huge, pretty big problem that I'm surprised we didn't get an error for. Okay. And so now we've got this kind of updater module thing. And actually that probably could be a module. It doesn't need to be a class. All right. And so we have this kind of updater namespace. We have a factory method within it. And we're able to create based on this constant. And so let's quickly take a peek at the Gilded Rose kata requirements. Now that we're in a spot where I think we can actually add the item. We'll take a look at requirements. So this is the interesting thing is conjured items degrade in quality twice as fast as normal items. So one of the things that we should probably do right now, just because we've been calling basic item updater, we should probably call that normal item. And it actually probably goes normal updater. It's probably what we can. And it's not clear that if conjured items are like a new item with like a new item name, or if conjured items are a new like kind or category of items. Honestly, that's going to really affect whether or not, or what we do next. I think with our current setup, it's easy to add new items it's easy to add items with new names. It's not necessarily easy to add items or to add kind of new item modifiers, if that makes sense. And it probably doesn't right now. I'm just looking at this code. We can simplify some things a little bit more. We've got if item quality is less than 50 in 2 places here, it's going to be true in this if it's true in the outer. And we're just going to simplify if. It's really great that refactoring lets you spot these kinds of things. Right. I wonder if that exists anywhere else. Probably not. All right. And so I think we're actually pretty much out of time, and I'm going to call it here. Yeah, we've only got a minute left. If you've gotten this far, thank you. Hopefully next time we can add the new, or add an item with the conjured name, and then maybe in the subsequent practices we'll look at how we would refactor from this, or maybe we don't rely on the method object extraction in order to get a Gilded Rose that introduces a new conjured item category rather than an item with a name conjured. Thanks very much for watching.